All right, welcome to the Explainer. Today we're tackling something absolutely fundamental in C++, header files. Seriously, this is going to completely change how you organize your code. We're going to go from, that one giant messy file to building your very first actual reusable library. You've typed this a million times, right? Hashtag include iostream. It's just muscle memory at this point. It's how we get stuff to print to the screen. But have you ever stopped to think about what's really going on? Like, what's the magic happening behind the curtain when you type that line?
Well, that line is pulling in what's called a header file, and you can think of it like a blueprint for code you can use over and over again. In the case of iostream, it's the blueprint that tells the compiler what count is and how it's supposed to work. The cool part? By the time we're done here, you'll know how to build these exact same kinds of blueprints for your own projects.
So to really get why header files are such a big deal, let's start where pretty much everyone begins their coding journey, shoving everything into one single file.
Okay, so take a look at this. It's a classic setup, right? We've got a little class, let's call it myInteger, and we've got our main function that uses it. All of it just crammed together in main.cpp. And hey, for a tiny project, it works. It compiles. It runs. No big deal. But, and this is a big but, the second your project starts to get even a little bit bigger, this whole approach just falls apart.
The thing is, this setup has some really nasty hidden problems. For starters, the code is what we call monolithic. It's just one huge, rigid chunk of text. As it gets longer, it becomes a nightmare to read and manage. But the biggest problem, by far, is that our poor myInteger class is basically trapped inside that one file. What if you want to use it in a different project? Your only choice is to copy and paste. And trust me, that is a one-way ticket to a world of pain and bugs.
So how do we fix this? We break free. It's time to create our very first header file. This is how we're going to separate our code and, finally, make it reusable.
And you know what? It's actually way simpler than you might think. First, you just create a new file, but you give it a .h extension for header. Then, and I mean this literally, you cut the entire class definition out of main.cpp, and you paste it into your new myInteger.h file. The final step? Back in main.cpp, you just add one simple line, #include myInteger.h. Boom, that's it. That one little line connects the two files.
So, what's the magic behind that #include command? Well, before your code ever gets to the compiler, another program runs first. It's called the preprocessor. Think of it as the compiler's assistant. When this assistant sees #include, it does a super simple but really powerful task. It finds the file you named, in this case myInteger.h, copies everything inside it and just pastes it right there, in your main.cpp. It's a glorified copy and paste job that happens automatically every single time you compile.
Okay, so what we've done so far works. It's a huge step up. But we're not done. We can take this to the next level. There's a much cleaner, more professional way to do this, and it's all about separating the what from the how.
Right, and this is a really important idea in professional software development. You draw a hard line between the what and the how. Your header file, it should just be the blueprint. It should only describe what your class can do, not the nitty-gritty details of how it does it. All that logic, all that implementation, that belongs in its own separate place.
And this is what that separation looks like. On the left, you've got your header file, myInteger.h. This is the public blueprint. It just lists the functions and variables. It's the what. Then, on the right, we create a new file, myInteger.cpp. This is like the private construction site. It's where you actually build the logic for all those functions. It's the how. And the key thing to remember is that this CPP file has to #include its own header. That's how the compiler can check that the code you wrote actually matches the blueprint you promised. Okay, so now we have this beautiful, clean, three-file system. It's professional, it's organized, and it's hiding a brand new problem. A really subtle but dangerous problem that can bring your entire program to a screeching halt. So what happens if you accidentally include the same header file twice? Now, in a tiny program like ours, you'd probably never do that on purpose. But imagine a huge project with dozens or hundreds of files. You might have one file that includes myInteger.h and another file that also includes myInteger.h. If your main program then includes both of those files, well, you've just accidentally included myInteger.h twice.
And what's the result? Remember our little friend, the preprocessor? It doesn't know any better. It just does its copy-paste job. So it's going to paste the entire definition of your myInteger class into the code twice. The compiler then looks at this and completely panics. It sees two definitions for the very same thing, and it throws a big, ugly redefinition error. It's a hard rule. You can't define something more than once.
So wait a minute. We've all included standard headers like iostream all over the place, and it never causes an error. So how do they do it? How do the pros solve this problem? Well, the answer is a clever little trick called a header guard. A header guard is just a simple but really smart trick that uses those same preprocessor commands. It basically wraps your entire header file in a little conditional check. It's like putting a gatekeeper at the entrance to your file that only lets the compiler in once.
Here's how it works. It's just 3 lines of code. At the very top of your header, you write #ifNotDefined. That's if not defined. It's asking the preprocessor, hey, have you ever seen the name myIntegerH before? The very first time it reads the file, the answer is nope. So it continues to the next line, which is #define myIntegerH. This line immediately tells the preprocessor, okay, well, now you've seen it. Remember this name. Then all your code goes in the middle. And at the very bottom of the file, you put #endif. So what happens the second time the preprocessor tries to include this file? It gets to that first line, #ifNot, and asks, have you seen this name? And this time the answer is, yep, I have. So the condition is false, and the preprocessor just skips everything all the way down to the #endif. Problem solved.
So by doing all this, by separating the blueprint from the implementation, and by protecting it with these header guards, you've done way more than just tidy up your project. What you have now is this perfectly organized system. You've got main.cpp, which is just your program, the thing that uses the class. You have myInteger.h, which is the public blueprint that anyone can look at to see what your class does. And then you have myInteger.cpp, which is the behind-the-scenes implementation that contains all the secret sauce.
And this is the whole point. This is the big takeaway. Your myInteger.h and myInteger.cpp files, together, they are now a self-contained, totally reusable component. You can literally just drop those 2 files into any new project you start, add that one #include line, and boom, all that functionality is there for you. You've gone from just writing one-off programs to actually building your very own library of tools. Honestly, this technique is the bedrock of pretty much all large-scale C++ development. It unlocks a totally new way of thinking about code, organized, efficient, and way more powerful. So really, the only question left is, now that you know how to do this, what's the first thing you're going to build?